Space exploration before the space race? Space exploration, as we understand it, today launching artificial objects and ultimately humans into outer space, might seem a distinctly 20th century endeavor. Nevertheless, its intellectual and technological roots extend deep into human history. Driven by astronomical curiosity, practical navigation, and the relentless quest to expand the boundaries of knowledge and possibility. Astronomical curiosity and early science. Humanity's fascination with the cosmos predates all recorded history. Ancient civilizations such as the Babylonians, Chinese, Mayans, Greeks, and Egyptians developed sophisticated systems for observing and predicting the motions of celestial bodies. They constructed observatories, made detailed sky charts, and devised complex calendars and myths in tribute to the movements of the sun, moon, planets, and stars. Notable is the Antikythera mechanism, circa 2nd century BCE, an intricate Greek device used to predict astronomical positions and eclipses, reflecting the era's scientific ambitions. From the Renaissance onward, advances in scientific thought reshaped humanity's understanding of the cosmos. The invention of the telescope by Dutch optician Hans Lippershey in 1608, and its subsequent refinement and scientific application by Galileo Galilei, opened vast new frontiers for inquiry. Galileo's telescopic observations in 1609 and 1610, revealing moons orbiting Jupiter, the phases of Venus, and the rugged lunar surface, undermined centuries-old geocentric models, and set the stage for a profound intellectual revolution, laying theoretical foundations for space travel. While celestial observation flourished, concepts of venturing into space remained the stuff of dreamers, philosophers, and the realm of myth or fiction. However, seeds of modern rocketry and spaceflight began germinating in the imagination of scientists and writers. During the 19th and early 20th centuries, Jules Verne's From the Earth to the Moon and H.G. Wells' The First Men in the Moon offered popular visions of lunar travel, inspiring generations. It was, however, the mathematical prowess and physical insights of a trio of early rocketry pioneers Konstantin Tsiolkovsky, Robert H. Goddard, and Hermann Oberth that translated fiction into plausible scientific vision. Tsiolkovsky, often called the father of modern astronautics, penned a pivotal work in 1903, The Exploration of Cosmic Space by Means of Reaction Devices. He not only proved mathematically that rocket propulsion could enable spaceflight, but also predicted multi-stage rockets, space stations, and even envisioned full-blown space colonies. Goddard, working in the United States, made rocketry practical by designing, building, and launching the world's first successful liquid-fueled rocket in 1926, near Auburn, Massachusetts. Across the Atlantic, Oberth, a Transylvanian German physicist, advocated rocketry's scientific basis, producing influential works in the 1920s and 1930s, and igniting widespread enthusiasm in Germany for space travel. Recre's early experiments and breakthroughs. The first half of the 20th century saw the formation of amateur rocket societies, most notably Germany's Verein für Raumschifffahrt, known as Spaceflight Society, and the American Interplanetary Society, which built and tested small rockets with limited means. Enthusiasts and inventors such as Jack Parsons, Max Valier, and Johannes Winkler contributed hands-on experimental knowledge, blending scientific rigor with a dose of seat-of-the-pants ingenuity. However, it was the march to war in the 1930s and 1940s that rapidly accelerated rocketry's progress. The most significant technological leap came from Nazi Germany's development of the A4V2 rocket. Designed under the direction of Werner von Braun, first launched successfully in 1942. By 1944, the V2 became the first human-made object to cross the Kármán line. The edge of space as defined by international convention, although conceived as a weapon of terror, the V2 marked the earliest point at which humankind penetrated the tenuous border of space. The end of World War II triggered a technological diaspora. The United States and the Soviet Union raced to capture German scientists and V2 technology through Operations Paperclip and Osovyachim, respectively. These personnel, including von Braun, would later become pivotal in launching the space age, popular culture, and the seeds of the space age. Though technological and scientific progress was crucial, cultural enthusiasm provided fertile ground for the space age. Stories of spaceflight were widely consumed, fueling dreams and ambitions. By the 1940s and 1950s, films like Destination Moon, comic strips, pulp magazines further inspired public interest. The idea of space exploration was no longer just science fiction, it was becoming a near-future possibility. Seeds sown, the space age begins. By the mid-1950s, a theoretical and practical foundation for space exploration was firmly established. Scientists and engineers had learned to design rockets, measure astronomical distances, and imagine and articulate the possibilities of leaving Earth. What had been a gradual gathering of knowledge and capability across centuries would, with the launching of Sputnik 1 in 1957, erupt into a new era, the space race. Thank you for watching. Like, subscribe, and stay tuned for the next video.